Hello everyone, my name is E. Sai Kumar and I am from ECE section. My topic is working of Hartley oscillator. Introduction of my topic: uh, the Hartley oscillator is an electronic oscillator circuit in which the oscillation frequency is determined by the tuned circuit consisting of capacitors and inductors. That is an LC oscillator. The Hartley oscillator was invented by Hartley while he was working in the research laboratory of the Western Electric Company. The circuit was invented in 1915 by the American engineer Ralph Hartley. What are Hartley oscillators? Hartley oscillator is inductively coupled and it's a variable frequency oscillators where the oscillator may be a series or shunt fed. Hartley oscillator is the advantage of having one tuning capacitor and one center tapped inductor. This procedure simplifies the construction of a Hartley oscillator circuit. And this is the circuit diagram of the Hartley oscillator circuit representation. It consists of one inductor and the variable capacitor and the transistor and a power supply. Hartley oscillator circuit and working. The circuit diagram of the Hartley oscillator consists of an NPN transistor connected in a common emitter configuration. It works as the active device in amplifier stage. R1 and R2 are biasing resistors. C1 and C2 are the coupling capacitors. L1 and L2 are the inductance. And the RFC is the radio frequency choke, which provides the isolation between AC and DC operation. At high frequencies, the reactance value of this choke is very high, so it can be treated as an open circuit. The reactance is zero for DC condition, hence causes no problem for DC capacitors. The CE is the emitter bypass capacitor. RE is also be a biasing resistor, and the CC1 and the CC2 are the coupling capacitors. When the DC supply VCC is given to the circuit, the collector current starts rising and begins with the charging of the capacitor C. Once capacitor is fully charged, the collector current starts rising and begins with the charging of the capacitor C. Once capacitor C is fully charged, it starts discharging through L1 and L2 and again starts charging. This back and forth voltage waveform is a sine wave which is a small and leads with its native alternation. It will eventually die out unless it is amplified. Now the transistors comes into the picture. The sine wave generated by the tank circuit is coupled to the base of the transistor through the capacitor CC1. Since the transistor is configured as a common emitter, it takes the input from tank circuit and inverts it to a standard sine wave with a leading positive alteration. The transistor provides amplification along with the inversion to amplify and correct the signal generated by the tank circuit. The mutual inductance between L1 and L2 provides the feedback of energy from collector emitter circuit to the base emitter circuit. Now, the frequency of oscillations in the circuit is given by the formula F naught equal to 1 by 2 pi into 1 by 2 pi into root of L equivalent into C, where L equivalent is the total inductance of coils in the tank circuit is given as L equivalent equal to L1 plus L2 plus 2M. M is the mutual inductance. For a practical circuit, if L1 equal to L2 equal to L and the mutual inductance are neglected, then the frequency of oscillations can be simplified as F naught equal to 1 by 2 pi into under root of root LC. Now the Hartley oscillator can be implemented by using an operational amplifier. This type of circuit facilitates the gain adjustment by using feedback resistance and input resistance. There is a operational amplifier section using an operational amplifier. In transistorized Hartley oscillator, the gain depending upon the tank circuit elements like L1 and L2, whereas in op-amps oscillator, gain is less depends on the tank circuit elements, hence provides greater frequency stability. The operation of this circuit is similar to the transistor version of Hartley oscillator. The sine wave is generated by the feedback circuit and it's coupled with the op-amp section. Then this wave is stabilized and inverted by the amplifier. And then the frequency of an oscillator is varied by using a variable capacitor in the tank circuit. Keeping the feedback ratio and the amplitude of the output is constant for over a frequency range. And now the frequency of oscillations for this type of oscillators is same as the above discussed oscillator and is given as f naught equal to 1 by 2 pi under root of L equivalent into C, where we know the L equivalent equal to L1 plus L2 plus 2M. And now the 2M is neglected, then it becomes L equivalent equal to L1 plus L2. To generate the oscillation from the circuit, the amplifier gain must and should selected greater than or at least equal to the ratio of two inductance. That is, voltage gain AV equal to L1 divided by L2, L1 by L2. If the mutual inductance exists between L1 and L2, because the common core of these two coils, then the gain becomes AV equal to L1 plus M by L2 plus M. Instead of two separate coils, L1 and L2, a single coil of bare wire can be used and the coil grounded uh, at any desired point along it. By using a variable capacitor or by making a core movable, varying the inductance, frequency of oscillations can be varied. Where few components are needed, including either two fixed inductance or a tapped coil. The amplitude of the output remains constant over the working frequency range. And now the disadvantages of Hartley oscillator. It cannot be used as a low frequency oscillator since the value of inductors becomes large and the size of the inductance becomes large. The harmonic content of in the output of this oscillator is very high. Hence, it is not suitable for the applications which require a pure sine wave. The applications of Hartley oscillator are the first one is the Hartley oscillator is to produce a sine wave with the desired frequency. Accurate sine wave will be uh, produced from the Hartley oscillator output. Hartley oscillators are mainly used as radio receivers. Due to its wide range of frequencies, it is most popular oscillator. The Hartley oscillator is suitable for oscillations in RF radio frequencies range up to 30 megahertz. And the conclusion of the topic is this is all about the Hartley oscillator circuit theory, working, and applications. And now the personal feature of Hartley oscillator is that the tuned circuit consists of a single capacitor in parallel with the two inductors are in series or in single tapped inductor, and the feedback signal needed for oscillation is taken from the center connection of the two inductors. Thank you.